We'll now look at some additional AND examples. Our first example says, 2 cards are to be selected without replacement from a deck of cards. Determine the probability that 2 hearts will be selected. So we're being asked to find the probability that we select 2 hearts. Which essentially what that means is that we want to be sure that the first card we select is a heart. So I'm going to write heart 1. And we want to be sure that the second card we select is also a heart. And so what we're doing is we're rewriting the problem so that it has an and in between the 2 events. We know that our formula tells us that if we have an and problem, that we can break the probabilities up separately and multiply the results. And so that's going to be the next thing I write. I'm going to simply make this 2 probability problems. And where there's an and, I'm going to put a multiplication following our formula. Then we'll look at each probability separately. So the first card that we pick, we want to be sure that it's a heart. And so what is the probability that the first card drawn is a heart? We know that there are 13 cards in the deck that are hearts, and there are 52 cards altogether. And so the probability that the first card drawn is a heart is 13 out of 52. Now, notice in the problem we are told that we are doing this experiment without replacement, which means that the heart that we just selected for the first card is not replaced in the deck of cards. And so, in other words, we're holding that heart out. So when we look at our probability for the second event, how many hearts remain in the deck? If I'm holding the first heart out, there are only 12 remaining. And how many cards altogether? If I have 1 card that I'm holding out, then the other 51 cards remain in the deck. And so we're multiplying 13 over 52 times 12 over 51. And when we do that using our calculator, 13 times 12 is 156. And 52 times 51 is 2,652. And we'll use our calculator, or you can reduce by hand, either way. And when we reduce this fraction, we come up with a final answer of 1 over 17. Let's look at a second example. A new medicine was given to a sample of 25 patients with flu symptoms. Of the total, 19 patients reacted favorably, 2 reacted unfavorably, and 4 were unaffected. 3 of these patients were selected at random. Find the probability that all 3 reacted favorably. So we're looking for the probability that all 3 reacted favorably. So what we want to do is try to rewrite the problem so that it has an and in it, just like we did on the previous example. So what does it mean that all 3 reacted favorably? It means that the first patient reacted favorably. And I'm going to go ahead and put my multiplication in. The second patient reacted favorably. I'm going to abbreviate here a little bit. And again, I'm going to put in a multiplication. The third patient reacted favorably. And so let's look now at each of those three probabilities. When I select my first patient, what is the probability that that patient reacts favorably? We know that there are 25 patients altogether, and so that's going to be the denominator on the first probability. And we know that of those 25, 19 patients reacted favorably. So I'm going to put 19 on the top. And that'll be the probability that the first patient selected reacts favorably. Well, what about the second patient? Now, keep in mind that once you have selected a patient and you know that that patient reacted favorably, that patient is then removed from the total. So now we don't have 25 patients to look at, but we have 24, because we already know that the first patient reacted favorably. So how many are left to react favorably? We started with 19, now we're down to 18. What about our third patient? We now have 2 patients that have been pulled out of the pool, so the 25 patients that we started with is now down to 23. We also have 2 patients that were pulled out of the favorably pool. So we started with 19 there, now we're down to 17. And so we're going to multiply these 3 together to get our final answer. 19 times 18 times 17 gives me 5,814. And for the denominator, 25 times 24 times 23 gives me 13,800. And again, we want to reduce that fraction. The easiest way to reduce that is going to be to use your calculator, but you could certainly reduce it by hand. And we end up with 969 over 2,300. And that will be our final answer for part A. All right, part B says that we want the probability that the first patient reacted favorably, the second patient reacted unfavorably, and the third patient was unaffected. And I have just copied down here the information about our problem so that we can work things a little bit easier. Okay, so let's go ahead and set this thing up. We want to know the probability that the first patient, and again, I'm going to try to abbreviate, first patient reacted favorably, and I'm going to put a multiplication for my ands. The second patient we want to react unfavorably, and another multiplication, we want the third patient to be unaffected. And so let's look at each of these probabilities. What's the probability that the first patient reacts favorably? We know that there are 25 patients in all at the beginning, and we know that 19 of those patients react favorably. Now remember that that patient that reacts favorably has now been pulled out of the group. And so the total is now down to 24. And how many of those 24 react unfavorably? We know that the patient that was pulled out was a favorable patient. So this number is down to 18, but this number is staying at 2. And so we have 2 patients that reacted unfavorably out of 24. Okay, now we're moving on to the third probability. We've now reduced that to 1. So our total number of patients, 18 and 4 and 1, makes 23. And how many of those are unaffected? We have a total of 4 that were unaffected. And so we're going to multiply these 3 together. 19 times 2 times 4 gives me 152. And on the bottom, 25 times 24 times 23 gives me 13,800. And again, we need to reduce that either on your calculator or by hand to give you 19 over 1725 as your final answer. All right, let's look at part C of this problem. We want now the probability that no one reacted favorably. So what does that mean? We're still selecting 3. That means the probability that the first patient does not react favorably. And we want the second patient to be someone who does not react favorably. And we want the third patient to be someone who does not react favorably. All right, so let's look at each one of these. Again, when we start, we know that our pool of patients is 25. And so that's going to be our denominator on the first fraction. Now, how many of those 25 do not react favorably? Well, we know that 19 patients do react favorably, so that means that there are 2 and 4, making a total of 6 that do something else. And those are the 6 that we want to look at. All right, what about our second patient? Now remember that we have pulled out one patient who does not react favorably. So either this 2 or the 4 has been reduced by 1. And so the total number of patients is now down to 24. And instead of having 6, we now have 5. And again, for the third patient, we know that we have 2 patients that have been pulled out, leaving me a total of 23. And those 2 patients that were pulled out either came from this group, or a combination of the 2. And so we are not at 6 anymore, but we are at 4. We have 2 patients already pulled out. And so we'll multiply this together. 6 times 5 times 4 gives me 120. 25 times 24 times 23 gives me 13,800. And we'll reduce that on our calculator to 1 over 115. All right, so as we move to part D, which is our last part of this example, we want to keep in mind that what we found in part C, because I think it's going to be helpful, we found the probability that no one reacted favorably to be 1 over 115. So I'm going to go ahead and write that down so we don't forget it. The probability that none reacted favorably, this is what we found in part C. We found that to be 1 out of 115. All right, so let's look at part D. Part D says that we want to find the probability that at least one of those patients reacted favorably. So we need to think about what this is asking us to do, because it possibly could be kind of complicated. At least one means 1 or more. So when it says at least one patient reacted favorably, we have a couple of different options that we could consider. We could consider one patient who reacted favorably, and we're selecting 3. So that would be 2 patients who did not react favorably. So that's one possibility. For what this problem is asking for. When it says at least 1, it could be that 1 reacted favorably and 2 did not. Another possibility could be that 2 patients reacted favorably and 1 did not. That would still be 3 patients where at least 1 reacted favorably. And we also have the possibility that all 3 reacted favorably. That would still be 3 patients where at least 1 reacted favorably. Now, if we're going to work this problem as it's asked, then essentially what we're going to have to do is treat this like 3 separate problems. a problem here, a problem here, a problem here, and we're going to have to work out each one, which is a considerable amount of work. Sometimes it might be easier to actually do the opposite of what the problem is asking for. So let's consider for a second the outcome that is not listed right here. Now, keeping in mind it may not actually meet the criteria of the question, but what else could happen if we select 3 patients? The other possibility is that we end up getting 0 that react favorably. And in that case, we would have 3 that did not. Now, this part is actually part C. Look at your wording up here. We found the probability that none reacted favorably, which is what we have right here when we say that 0 reacted favorably. So we already know that this part is equal to 1 over 115. And so the easiest way to deal with answering this part of the problem is to remember that if we take all of these 4 events and put them together, we end up with a probability of 1. We end up with a 100% chance that one of these outcomes is going to happen. And so we can sort of back into our answer up here by saying that we know that the answers have to add up to be 1. And so if this is 1 over 115, then this up here as a total had to have been 114 over 115. Because again, we need this probability and this probability together to represent the whole, which is equal to 1. And so our final answer on this would be 114 over 115. Okay, and it might be worth noting, the book does give us a formula to do this, and the formula says that the probability of an event happening at least once is equal to 1 minus the probability of it happening none, or no times. All right, and so you can see that if we had just simply went by the formula, we could have done it a little more straightforward by saying that the probability of having at least one patient react favorably would be equal to 1 minus the probability that none reacted favorably. And remember that we already know that answer. So 1 minus 1 over 115. And again, that's going to give you 114 over 115 as your final answer.